All right, welcome. Today, we are diving deep into something I like to call the silent language that keeps our entire digital world from falling apart. See, it's this hidden series of conversations happening between all the software services we use every day. And in our modern microservices world, these conversations are happening constantly. If we as architects don't get them right, the whole system, maybe even the whole business, can just come crashing down. So let me ask you this right off the bat. Think about it. In any app you use, your bank, your social media, anything, there are dozens, maybe hundreds of these little background conversations happening for every single click you make. And as we're about to find out, just one single, slow reply in that whole complex web can be all it takes to trigger a complete catastrophe. And right here, this is the villain of our story today, the cascading failure. I want you to picture a line of dominoes. Service A needs something from Service B, so it makes a call, but Service B is slow, maybe it's got a problem, it doesn't answer right away. So now Service A is just stuck. It's hanging, waiting. But what about the service that called A? Well, now it's stuck too. The problem just ripples backward, freezing the entire system solid. For you, the user, this is that spinning wheel of death, the frozen screen, the dreaded application not responding error. This isn't just some little bug. It's a massive architectural flaw.
But there is a way to beat this villain, and it's a really powerful strategy that isn't just about making every single service faster. No, the real secret, the architect's hybrid secret, is understanding that not all digital conversations are created equal. You see, great architects master two totally different types of communication, and they use each one for a very specific job. This is how they build systems that aren't just fast, but are genuinely resilient.
Okay, so let's break down these two core principles. On one side, you have synchronous communication. The best way to think about this is like a live phone call. You ask a question and you literally wait on the line for an answer. You can't do anything else. Now, this is absolutely crucial for things where a user is waiting for immediate feedback, right? Like logging in or adding something to your cart. You need to know, did it work? Right now. But that's also where the danger is. If the person on the other end of the line puts you on hold forever, you're stuck. That's the cascading failure risk. Now, on the other side, we have asynchronous communication. This is completely different. This is like passing a note or sending a text. You write your message, you drop it in a mailbox, and you just go about your day. You're totally free. The person on the other end will pick it up and deal with it whenever they're ready. This completely decouples the two systems, and that creates incredible resilience. It's perfect for all those background tasks where the user isn't waiting, like writing to a log file or generating some report overnight. So, theory is great, but let's see how this actually works in the real world. We're going to follow a single customer order at the amazing Bookstore and see exactly how a smart architect uses both of these conversations, the live call and the pass note, all in one single seamless transaction. At a glance, this looks super simple, right? A customer clicks buy, and the system records what happened. But the real genius here isn't in what happens, it's in how these two steps talk to each other. The conversation between the user interface and the order service is fundamentally different from the one between the order service and the activity log, and that deliberate choice is what makes this whole thing work without breaking. So let's zoom in on step one. You've got a real person staring at their screen. They just typed in their credit card info, they clicked place order, and now they are waiting. Every single second that little spinner is turning, their anxiety is going up. Because a person's attention and their experience is on the line, this is a priority one interaction. This conversation has to be synchronous. It's a live phone call. The user interface needs an immediate blocking answer from the order service that says, "Success, we got your order. Here's your order number."
But here is the most important part. The second that user sees the confirmation screen, they're happy, they've already mentally moved on. Maybe they're closing the tab or looking for another book. Now ask yourself, do they care if a log file for analytics has been written somewhere in the background? No way, not at all. This is a priority two interaction. The system needs to do it, but the user is not waiting. So the order service doesn't make another live, risky phone call. Instead, it passes a note, asynchronously. This is a critical architectural choice. It protects the most important part of the whole process, the successful order, from a non-essential background task. If that logging service is slow, or maybe even down for a bit, it doesn't matter. The order is safe. The user's experience was perfect.
And this idea right here leads us to the real superpower of asynchronous design. It's a concept that lets our systems survive failures that would otherwise just be catastrophic. It's a bit of a mouthful, but it is a critical idea for any architect to master. Temporal decoupling. Now, temporal decoupling sounds fancy, but it's really just a term for a beautifully simple idea. Services don't have to be online at the exact same time to talk to each other. By using a message queue, that digital mailbox we've been talking about, one service can drop off a message and the other one can pick it up minutes or heck, even hours later when it's back online and ready to go. They are decoupled, across time. It is the fundamental difference between needing a live phone call, where both people have to be there, and just sending a text message, which waits patiently for the other person to be ready.
And the benefits here are just huge. First, the user experience is way better. It feels snappy and responsive because the user isn't stuck waiting for some background task they don't even know about. Second, your system stability just goes through the roof. Imagine the activity log service just fades offline. It's down. In a synchronous world, the entire order would fail. But here, the note about the order just piles up safely in that message queue, waiting patiently. When the logging service comes back online, it just starts working through its backlog, which of course leads to the third benefit, guaranteed delivery. Nothing gets lost, and the most important part of the business, taking orders, keeps running without a single hiccup.
So, okay, how do we actually put all of this into practice? Mastering these ideas is really what takes you from being a coder who's focused on making one single piece work to being a true solution architect who designs an entire system of pieces that can survive out there in the real world. It's all about moving from just making things work to making things resilient.
And that brings us to the architect's golden rules. These are the principles that really transform your code into a tough enterprise-grade system. Rule 1, standardize the language. Your services need a common way to talk. Using a universal standard like HTTP just ensures they can understand each other. Rule 2, ports are gates. Think of a port as a specific doorway into your service. You have to know which door to knock on to get the right response. Rule 3, use circuit breakers. This one is so critical. A circuit breaker is just like the one in your house. If a service you're calling is slow or failing, the breaker trips. It stops you from waiting forever, and that's what prevents the cascading failure. It's basically a smart automatic timeout. Rule 4, differentiate your errors. Look, not all errors are bad. A 500 internal server error means your system broke. Bad. But a 400 bad request error, that isn't your system failing. That's your system succeeding at rejecting bad data. It's a successful defense. And finally, Rule 5, the one that ties this whole thing together. Balance Principle 1 versus Principle 2. The question is simple. Is a real person waiting for an answer right now? If yes, that's priority 1. Go synchronous. If not, if it's a background task, that's priority 2. Go asynchronous for resilience. Every time.
And that brings us all the way back to where we started. But now you have a new way to look at it. So the crucial point is this. Which conversation in your system is currently designed like a fragile live phone call when it really ought to be a resilient, hand-delivered note? Finding that answer and then making that change, that is the first step to building truly unbreakable systems.